Hello, my Calc 2 student. We continue our chapter 9. Continue to talk about series and converges or diverges the series. And today we study two comparison tests. One of it is direct comparison test. And now we start with theorem. Remember, this is section 9.4. Theorem tell us, let's we have two tests with positive terms. Let's go, will be strong positive. And term 1 test is less or equal than term 2nd test for all n. Okay. Then we have first, if series Bn, let's start with 1 to infinity, converges, then series with lower term an converges. Second, if series an diverges, this means series with greatest terms Bn diverges. Looking how we can use this test. For example A. You have series where I have 1 over 2 plus 3 to the power n and start with 1 to infinity. It's almost geometric series, but not geometric. Almost, this means if I'm looking for series 1 over 3 to the power n and for 1 to infinity, it will be geometric series with r equal 1/3. This means the series is converges. Great, but how it work with, what kind of inequality you have? 1 over 2 plus 3 to the power n is always less, oh, practically less, not equal, 1 over 3 to the power n. Because we have less determinant, this means this fraction is greatest. It's work for all n. We found series whose term is greater than your series, and this series is converges because it's geometric series, r equal 1/3, it means converges. This means your series converges. Okay. See one more example. Example B. Here I have series 1 over 2 plus square root of n and start with 1 to infinity. We try and make it something less. This means we try looking series 1 over square root of n. This is P series, P equal 1/2, it means diverges. Okay, but we know 1 over 2 plus square root of n less than 1 over square root of n. But looking here, we have greatest series is diverges, but it doesn't give us any information about lower series. because we know for our theorem, if greatest series converges, this means lower series is converges. If lower series is diverges, this means greatest is diverges. But this kind of, it's not working. This means our second series, what we did it, is not work for this example. Okay, try build different example. Try build different series. What happened if I'm looking series 1 over n? N equal 1 to infinity. You know this is harmonic series and this series is diverges. I think it's only one series with diverges and have exactly own name. What we have here, we have 1 over n is less or equal than 1 over 2 plus square root of n. It's true or not? Try doing. Because this both of fraction is positive and numerical for both of fraction is equal 1, this means this inequality mean n greatest or equal 2 plus square root of n. It's true for any n greater than or equal 4. This means we found series 1 over n diverges and each element this series, each term this series, less or equal term series what we have before. This means our series 1 over 2 plus square root of n, and from 1 to infinity diverges. Now we have second theorem, second test. This test is called limit comparison test. Limit comparison. Test. And this test tells us if you have series with positive non-zero terms and limit fraction an over bn and approach to infinity equal L, where L is non-equal 0 and non-equal infinity. This means L is some real numbers. Then series an and bn either both converges or both diverges. Or either both diverges. How work this test? This means if you have some series and you have question about convergence or divergence in this series, you build second series about you exact now the series is converges or diverges. And if limit fraction or limit ratio, it will be some constant, non-zero and non-infinity. This means you can talk about what happened with first series. Okay, looking examples. Example. Let's go, we have series square root of n over n squared plus 1. And from 1 to infinity. I try build second series when I can easily find limit ratio and what I have some information about second series. What I do, I take it series and I'm not write constant 1. This means n square, and from 1 to infinity. Here is will be 1 over n. 2 minus 1 half, it will be 3 halves power. This is exactly p series. P series. It's p equal 3 half greater than 1. This means converges. Okay, we built second series. But what about limit? Limit, okay, square root of n over n squared plus 1 divided by 1 over n 3 halves power, and approach the infinity. Simplify, we have n times n 3 halves over n squared plus 1. Let's give me n squared plus 1. And this is exactly 1. 1 is non-zero, non-infinity, real number. This means, because my second series is converged, this means my first series is converges too. This means our final answer, series root of n over n squared plus 1, 1 to infinity, converges. Okay. Doing a couple of examples. First couple of examples for direct comparison test. This means our first test. Okay. Number 4 from your book. Here we have n from 1 to infinity, 1 over 3n squared plus 2. Okay. I think it's our second series will be 1 over 3n squared. What you know about this series? Use property of series. We can 1/3 go to out, and we have 1 over n squared. Now we have p series, p equal 2 greater than 1, converges. Yes. And now we need only prove our inequality. This means 1 over 3n squared plus 2 which be less than 1 over 3n squared. Okay, great. Positive. Both of fraction is positive. Both of fraction have numerical 1. This means less fraction have greatest determinant. And 2 greater than 0. True? True. This means we build second series is correctly. Greatest series is converged. This means lower series is converged too. Use our first theorem. We say this series is converges. Okay. Doing one more example. Number 8. Here we have series 1 over square root for n cubed plus 1, n equal from 1 to infinity. Same trick. This means build second series when it's like coefficient is 1 is not exist. This means here you have n from 1 to infinity, 1 over square root from n cubed, 1 over n to the power 3 halves, p series with p equal 3/2 greater than 1, this means converges. Okay, now we try checking our inequality. M cubed plus 1 less than 1 over. I write it this way. It's mean square root n cubed plus 1 will be greater than square root from n cubed. You can square it and simplify if you have 1 greater than 0. True, true. This means our series 1 over cube root from square root, sorry. Square root from n cubed plus 1 converges. I'm doing last for this theorem. It's number 12. Let's go. We have series where n start with 1 to infinity, 3 to the power n over 2 to the power n minus 1. Build second series. What we have? 3 to the power n over 2 to the power n. Start with 1 to infinity. It's like you have what I write limit, sorry. Tell me please. Series 3 half to the power n with 1 to infinity. But what we have here? Here we have geometric series with r equal 3/2, who is greater than 1. This means our series is diverges. Okay, now we need only check our inequality. 3 to the power n, 2 to the power n, less than 3 to the power n over 2 to the power n minus 1. Because numerical is same, this means 2 to the power n minus 1 need be greater than 2 to the power n. What is greatest? Lower, because fraction is greatest. This means here is we have lower. And this means -1 less than 0. True? True. What we build, or what we prove? We prove our series. It's 3 to the power n over 2 to the power n minus 1. And from 1 to infinity diverges. Now solving a couple of examples about our second theorem, limit comparison test. Let's go number 16. Sum 1 from 1 to infinity. Okay, build second series. What we have here? 2 to the 5th power n. It will be geometric series. With r equal 2/5, positive number less than 1. This means series is converges. Okay. Converges. And we need found limit and approach to infinity. 2 to the power n plus 1. 5 to the power n plus 1. Divide 2 to the power n. 5 power n. Right, normally we have 5 power 1 and approach to infinity, and this limit will be 10 power n 5 power n over 10 power n plus 2 power n divide by 10 power n, and you have 1. Okay, great. This means our series 2 power n plus 1 over 5 power n plus 1 converges. Doing one more example, 20. This means next example. N over n plus 1 times 2 power n minus 1, and from 1 to infinity. I build second series. It will be 1 over 2 power n minus 1. This is geometric series with r equal 1/2, positive number less than 1, this means converges. And now we are looking for limit. We have n over n plus 1 2 power n minus 1 divided by 1 over 2 n minus 1 infinity. Okay, simplify a little bit here, there. Don't forget n approach to infinity, n over n plus 1, it will be 1. Okay, this means converges. And one more very interesting example. Here we have series sine 1 over n from 1 to infinity, and question, what kind of second series we can build? I think because we need, remember, we need limit. This means we take it 1 over n series, n from 1 to infinity. This is harmonic series. And the series is diverges. But what happened with limit? Limit sine 1 over n, 1 over n approach to infinity. If n approach to infinity, 1 over n approach to 0. Let's go 1 over n is some x, and then I have limit sine x over x approach to 0. We know this is special limit is equal 1. Who not remember what is it? Use L'Hopital rule and easy found this limit is equal 1. But what kind of information we have? We build equivalent series who is diverges. This means our series sine 1 over n, and from 1 to infinity is diverges. And now I'm showing you a couple of examples when you don't use this test what we study now, but it's a refresh what kind of test you need to use. This means it's all depend what kind of series you have. For example, number 24. I have 5 times negative 4 third to the power n, and start, I forgot to write, I think it's n from 1 to infinity or 0 to infinity. It's no big deal. Here we have geometric series which are equal negative 4/3. Absolute value negative 4/3 is greater than 1. This means series is diverges. Okay. What about number 26? We have series 1 over n cubed minus 8. Be careful. Here is number 26. This sorry. In the book you have n start with 2. N cannot start with 2 because if n equal 2 you have 0 in your denominator. This means n start with 3 to infinity. I think here is better use limit comparison test for series 1 over n cubed. This is p series with p equal 3 greater than 1 converges. And you can easily show limit 1 over n cubed, 1 over n cubed minus 8, limit n, oops, not m, n cubed minus 8 over n cubed, and approach to infinity, and this limit is equal 1. This means both the series is converges. This means your series 1 over n cubed minus 8 converges. Whereas n start with 3 to infinity. Okay, and last one, 28. Series n equal 1 to infinity, 1 over n plus 1 minus 1 over n plus 2. We have our lovely telescopic series. This means only write couple of first term. You have 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 and continue. How long you want? The series is exactly equal 1/2. Telescopic series. Telescopic converge. Now you have couple of more tests for solving problem and for found series is converges or diverges.